This
connection with
conference
Pi
will now be
Approximation.
recorded.
Conducted in connection with Pi Approximation Day celebrations by the Department of Mathematics, Sacred Heart College, Chalakudi. So, let's start today's session with the blessings of Almighty. That
This
I
conference will
request
now be
Henna of
recorded.
2nd PG, Christy of 2nd DC, and Ashley of 3rd DC to use the platform.
Good afternoon to one and all. I'm Ashley Shajan of 3rd DC Mathematics. First of all, thank you for giving such a beautiful opportunity. Now let's start. Let's start. I'm pretty much eager to say an introduction for this section. We can now discuss something about pi. Yes. Now, what is pi? What does that name means? Pi is the most recognized mathematical constant in the world. Pi is rather than some other Greek letter like alpha or omega. Pi was chosen as a letter to represent the number 3.141592 because the letter pi in Greek pronounced like our letter P, which stands for perimeter. And also, pi is the 16th letter of the Greek alphabet. Pi is the ratio of the circumference of a circle to its diameter, where pi is equal to c by d. That means c is equal to circumference and d is equal to diameter. Here the ratio c by d is constant regardless the circle size. This definition of pi is not universal because in Euclidean geometry and is not in fractional form. The value of pi is 22 by 7. Pi is an irrational number. It's not equal to the ratio of any two numbers, which makes it as irrational. We all have heard about Pi Day. Wow, we celebrate our own birthdays, no? Yes, March 14th is celebrated as Pi Day. Pi Approximation Day is observed on July 22nd. Who first approximated pi? Archimedes is one of the great mathematicians of the ancient world. He was the first to obtain a theoretical calculation of pi, and also the first to use the symbol pi was William Jonas in 1706. Yes, now we can hear a quick info about the history of pi. Throughout the history of mathematics, one of the most enduring challenges has been the calculation of the ratio between a circle's circumference and diameter, which has came to be known by the Greek letter pi. From ancient Babylonia to the Middle Ages in Europe to the present day of supercomputers, mathematicians have been striving to calculate the mysterious number. They have searched for exact fractions, formulas, and more recently, patterns in the long string of numbers starting with 3.141592653, which is shortened to 3.14. The people who initiated the hunt for pi were the Babylonians and Egyptians nearly 4,000 years ago. It's not clear how they found their approximation for pi, but one source makes the claim that they simply made a circle, and then measured the circumference and diameter with a piece of rope. They used this method to find that pi is slightly greater than 3 and came up with this value 3.125. A famous Egyptian piece of papyrus gives us another ancient estimation for pi, implying that pi is equal to 3.16049 in Rhine papyrus written by a scribe named Amos. The first man to really make an impact in the calculation of pi was the Greek Archimedes of the Syracuse. Archimedes focused on the polygon's perimeters as opposed to their areas so that he approximated the circle's circumference instead of that area, implying the value of pi calculated between 223 by 71 and 22 by 7. Near the end of the 5th century, Zhou Zhang and his son came up with astonishing results, and they calculated as the value of pi as 355 by 113. Soon after, the mathematician Aryabhatta gave the accurate value of pi as 3.1416. Another Indian mathematician, Brahmagupta, took a novel approach and calculated the value of pi as root 10, that's equal to 3.1622. Then Al-Khwarizmi in 1430 calculated pi into 14 decimal places. Then Newton in 1665 calculated pi into 16 decimal places. Then Ferguson in 1946 calculated pi to 620 decimal places. This is a brief history of pi. The next section is carried out by Christy. And thank you all for hearing me.
Myself, Christy Rose of Second EC Mathematics. Some people become famous by discovering ways to calculate pi such as Archimedes, Leibniz, Wallis, Machin, Sharp, Euler, Bouncer. Now I'm going to discuss in detail about the Archimedean method of finding pi. Around 200 BC, Archimedes divides the method for calculating pi by Archimedes method. First, we create a circle radius of 1.5. Now, remember, it is the circumference of circle 2 pi r with radius of 1.5, the circumference equal to pi. Next, inside the circle, we inscribe a polygon and we increase the number of sides repeatedly. What we can see is the every time we increase number of sides, that polygon that more resembles the shapes of the circle. Specifically, the perimeter of the polygon approximates the circumference of the circle. So, let's derive the formula to calculate the perimeter of the inscribed polygon with an arbitrary number of sides. We know the radius is 1/2 and we call the center of the polygon point A with point B and C. And point A, we construct line AD such that it is perpendicular to line BC. And incidentally, point D bisects line BC. So, triangle ABD is right triangle with sides A, B and C. Also, length A. Now, in order to find the perimeter of the equilateral polygon, we must find the length of one of its sides. Using trigonometry, we know that sine of theta equal to the opposite side over hypotenuse. Looking at a right triangle, we can see that the side opposite angle theta is A and the hypotenuse is 1/2. So A over 1/2 simplifies to 2A. Next, looking at the one of the sides of the polygon, we can see that it is actually equal to A plus A, which simplifies to 2A. Therefore, the length of the side of a polygon is equal to sine of theta. The perimeter of the equilateral polygon is defined by the number of sides times the length of the side. We will simplify by replacing the number of sides with n so that the perimeter equal to n times side. But we know that side equal to sine theta. Therefore, the parameter equal to n times sine of theta. Finally, we must find what angle theta equal to. If we connect all the vertices of the polygon to the center, we can see that each individual angle 360 is divided by number of sides of the polygon, and theta just equal to 1/2 of one of those angles. So theta equal to 180 degree over n. Therefore, the perimeter of the polygon equal to n times sine of 180 degree over n. So looking back, outer circle with the circumference equal to pi. We can understand why increasing by the value of n approximate the value of pi, because the perimeter of the inscribed polygon with more sides approximate the circumference of the circle. Next section is carried out by Hannah Thomas. Thank you.
Okay, myself is Henna Thomas of 2nd MSc Mathematics. Moving on to some interesting facts on Pi. As we all know that Pi Day is an annual celebration of the mathematical constant pi. The day is observed on March 14th, which was chosen because it resembles with the first three significant digits of pi, that is 3, 1 and 4. Pi Approximation Day is observed on July 22, since the fraction 22/7 is a common approximation of pi. Another interesting fact of pi is that the number 3.14, when written backwards, looks like the word pi, P-I-E. Leonhard Euler, a mathematician, popularized the use of Greek letter pi in a work he published in 1737. It's regularly used for past 250 years. In the decimal value of pi, at position 763, there are 6 nines in a row. This is known as Feynman point. Egyptologists and followers of mysticism have been fascinated for centuries by the fact that the Great Pyramid at Giza seems to approximate pi. The vertical height of the pyramid has the same relationship to the perimeter of its base as the radius of the circle has to its circumference. A crop circle discovered in a barley field in Wiltshire measures 150 feet in diameter and is apparently a coded image representing the first 10 digits of pi. Physicist Larry Shaw launched the first Pi celebration in 1988 at San Francisco Science Museum. He is known as the Prince of Pi. The record for most digits of pi memorized is held by Rajiva Meena of India. He recited 70,000 decimal places of pi in 2015. The famous theoretical physicist Albert Einstein celebrates his birthday on Pi Day. He was born on 14th March 1879 in Germany. Next, we can look for some applications of pi. We all are familiar with pi in geometry and trigonometry. Well, pi appears in formula for areas and volumes of geometrical shapes based on circles such as ellipses, spheres, cones, etc. Some of the most common formula that involve pi is circumference of the circle, which is 2 pi r, area of a circle, pi r square, etc. It is also used in trigonometry to get the values of trigonometric functions like sine, cosine, tangent. Pi is also used in chemical fields. Biochemists use pi to accurately describe the geometry and function of the DNA. Doctors use pi to study the structure of the eye. This process is done to produce people with eye medicine such as eye drops. Pi is also used in clock designing. Clock designers use pi when designing pendulums for clocks. They need to work out the length to the center of mass so that they can set the initial length of the pendulum. To do this, they use formula L equal to T square G by 4 pi square, where pi is necessary for the calculations. You have probably heard of sine waves. Well, sine waves have a fundamental period 2 pi. So, pi becomes vital in signal processing and spectrum analysis. Pi is also used for estimations, testings, and simulations. It is also used by mechanical engineers to design and build aircrafts, cars, and other heavy machineries. Aircraft workers use pi to find areas of the aircraft's outside structure. So, dear friends, it's been a long time since we started hearing about the term pi. No matter whether mathematics is your core subject or not, but we started using pi and still continue using it from the very first moment when we learned about circles. So I thank the entire mathematics department of our college for organizing such a program. Thank you and have a nice day.
Thank you, my dear ones. I think you get an idea about what pi and why pi. Next, I would like to invite Smita ma'am, Head of the Department of Sacred Heart College, Talakudi, to officially welcome our resource person, Aishwarya ma'am.
Good afternoon, dear ones. It's indeed a great pleasure that even in the virtual platform, we are all together again. So, first of all, I would like to welcome all of you to this event related to Pi Day. In fact, Pi Approximation Day. And first of all, I would like to congratulate Henna, Ashley, and Christy for their excellent presentation. That was awesome. They were asked to do the presentation in a short notice, and they have made it excellently well. I'm really proud of you. Now, I would like to welcome our guest, our presenter, our talk for the day, Miss Aishwarya Paul. She is Assistant Professor and head of the department at Providence Women's College, Kozhikode. She has graduated from Sacred Heart College, Tevra, Sacred Heart College, Tevra, and has done her post-graduation from Maharajas College and MPhil from Cochin University of Science and Technology. Her areas of specialization include semigroups and Lie algebra. She's a very vibrant person and a very beautiful, charming person. We welcome you, ma'am, to our Pi Day celebrations, and please inspire us with your wonderful talk. Aishwarya, ma'am.
Yes, ma'am. Thank you.
You can continue. Thank you, Aishwarya.
Okay. Okay. Good afternoon, all of you. Respected head of the department, Smita ma'am, dear teachers and students. Let me first of all appreciate the efforts taken by this department in such a pandemic situation to organize a program, to keep you all together, to keep up your zeal and your energy as it was before when you were in the college. We do not know when our college is going to reopen, but let us keep on doing such initiatives, such innovative ideas to innovate you, to give you an enthusiasm throughout while you are learning in this college. So we are here in connection with the Pi Approximation Day. Already you have heard so much about pi. I need not tell much, but I have to tell you one thing, that pi is an irrational number. Before, when people used to ask me what pi is, I used to tell it is just an irrational number. But then when I started thinking about it, we were not taught in the school that pi was the ratio between the circumference and the diameter and so on. But when we started thinking, we started to notice that pi is nothing but the ratio between the circumference and the diameter of any circle. Any circle means whatever, however large it is, however small it is, it can be a miniature circle. Whatever it is, the circumference divided by the diameter of a circle is a constant. And that constant is called pi. And now, in connection with Pi Approximation Day, I am here. There are 2 days in connection with Pi. One is the Pi Day that falls on the 14th of March. It falls on the very birth date of Albert Einstein, very important physicist and mathematician. You might be knowing he was the person who brought in the concept of summation and differential geometry. And this coincidence is called the pi coincidence. That is the coincidence of the fall of the birth date of Albert Einstein and the pi day is called the pi coincidence actually. So that is one day, and the next day is 22nd of July, which is the pi approximation day. So I need not talk much about it because we have seen a very beautiful presentation of it. Now I'm just here to talk about what mathematics is. Just about mathematics. Mathematics, as you know, is a very abstract subject. Now, what is abstract? Abstract means it just has got ideas. Like the very basic of mathematics is just ideas. We cannot give you concrete things to show mathematics, isn't it? Like when we start learning mathematics, you know, we start with 1. We start 1, 2, 3, etc. But what is 1? Can you see 1? You cannot see 1. That is why it is called it is abstract subject. You can show what one apple is, or one student is, or one bird is, but you cannot see what 1 is. That is the reason why mathematics is found by some people at least a very drab subject, a subject which is very boring. So we mathematicians should be the ones who change that thought, that the thought of a boring subject. Maths has got something very special that is unlike every other sciences. In fact, maths is called the queen of sciences, isn't it? But unlike any other science, unlike botany, unlike zoology, unlike chemistry, unlike physics, Maths is the subject where we study application first and then only we move on to theory. Like till your second year of mathematics in the college, you study only the applications. It's only in your third year that you study the theory of how 1 plus 1 has become 2. Okay, so that is the very basics of mathematics. That is, you study applications first and then only you move to theory. That is a speciality of mathematics. So when my first year students joined our college, I gave them a bridge course telling about what you're going to learn in this course. And I told them, I asked them what 1 plus 1 is. They told me it is 2. But then I told 1 plus 1 need not be 2 always. Why? Because in the third year, we study a subject called abstract algebra. And in that, there are sets or groups where 1 plus 1 need not be 2, it can be 0. So I told them that now 1 plus 1 is 2. But after you study maths, after your BSc maths, 1 plus 1, if someone asks you what is 1 plus 1, you will say it can be 2. It's not actually 2, it can be 2. But then the students told me, then what we studied these many years, these 12 years, were wrong, ma'am? Actually, was that wrong? It is not wrong. It is correct. It is because we are using only a particular area of the number system or a particular set throughout the life or till at least second year of maths. That is the real number system or the complex system where 1 plus 1 is equal to 2, but there are areas where 1 plus 1 is not equal to 2. So there can be contradictions and confusions. There are so many contradictions and confusions in mathematics from the very day you started learning mathematics. But only mathematicians, only those who love maths can enjoy these contradictions, these confusions. So that is why I am here to make you see mathematics in a very different way. So my topic today is mathematics. Okay, what has happened? Okay, my topic is mathematics from a different perspective, where I try to answer at least some of the questions that at least some of you might have asked your teachers. Why maths? Why trigonometry? Why differentiation? Why profit? Why loss? Why integration? And so on. I'm trying to answer at least some of them. So shall we start with the presentation? So I'm here to present. I have prepared a PPT. Let me start the presentation, okay?
Yes, ma'am. You can share it.
Yeah, okay. Can you see it? Can you see the slideshow?
Yes. Yes, Aishwarya.
It's not a slideshow, but you can view the.
Now?
Yeah.
Now it's slideshow, I guess. Okay?
Yes, it's the slideshow.
Okay. So let me start with my
Yes.
presentation. Okay. I'm just offing out my video. Can I off my video 1 second? Because the data consumption is very much, that is why. Lynette, can you off my video if you can? I cannot access my video right now. Okay, let me start. So I'm here, I told you, I'm here to speak about mathematics from a different perspective. 1 second, let me just off the video and I shall speak about it. Okay, can you see the presentation? I cannot hear you.
No, ma'am.
Yes, can you see? No?
I think I cannot see it. Lynette?
Okay, 1 second.
Yeah, fine.
No. Yeah, okay. Okay. So my topic for today is mathematics from a different perspective. So every day in your life, you have mathematics, isn't it? You can see mathematics, or you have to come across mathematics in whatever you perform day to day in your life. That is from the very time you wake up from your bed, you look at the clock, you see mathematics there. You go to the kitchen, you ask your mother to give you a coffee. Your mother is playing with mathematics there. She takes 1 teaspoon of tea, 2 teaspoons of 2 teaspoons of sugar, and 1 cup of water or milk, whatever it is. She's playing with max, isn't it? Again, she asks you how much doshas you need or how much chapatis you need for breakfast. See, she's again using max there. She asks you to go to the shop and get her some groceries. Again, you have to play with max there because you have got money. You have to think how much I should buy and all. Again, you have got max there. But then you might be thinking, this is all very basic mathematics. You do not want linear equations or profit or loss or differentiation for all these, isn't it? But these are all required in your life, in your daily life, but maybe not directly to you. Okay, so let me show you how all these are there in your life. The first thing we study after we study the addition and subtraction and multiplication and the reciprocals or the division is profit, loss, percentage, and linear equations. So these concepts have got very important role in business and economy, which are two substantial things in the development of a country. In business, how is it related in business? Profit and loss, of course, in business, it is related very much. You all know that, isn't it? For example, if I am a chair manufacturer, I manufacture a particular chair and I try to sell it. If it clicks, that is, if the chair clicks and there is a high demand for the chair, what will I do? I'll again try to manufacture the chair, and the SP or the selling price will be bit by bit increased because I need profit, isn't it? If the demand keeps on increasing, I'll keep on increasing the selling price again bit by bit so that I have more and more profit. Now, if the chair is not needed by anyone, it is not in demand, what will I do? I won't make the chair again because that is a loss for me. So that is what in business how max is. That is what you know, isn't it? But what is this percentage in business? 100% profit, 50% profit, 200% profit. You might have heard all these said by very big corporate companies, isn't it? Or by Reliance or Tata and all. What is it? Suppose I buy a commodity for 50 rupees and I somehow sold it for 100 rupees. Then what is my profit? It is 50 rupees, isn't it? So I bought the commodity for 50 rupees. I have got 50 rupees extra with me, which means the profit is 100%. Now, what if I sell the commodity for 150 rupees? That is, I have got 100 rupees profit. Means what? I have got the profit of double what I have. That means I have only given 50 rupees, but I have got 100 rupees profit, which means it is 200% profit. So all these are terms in business, and very big corporates use this in their business. Now, how can linear equations be affected in business? Suppose I am manufacturing notebooks. I need paper and ink also for notebooks to draw lines, isn't it? Or to print lines. Suppose an ink bottle costs 10 rupees for me and a paper costs 1 rupee. I only have 1000 rupees with me. Then I will think how many ink bottles and how many papers can I buy with this 1000 rupees, isn't it? That is, suppose X is the number of ink bottles, suppose Y is the number of papers, then I try to solve the equation 10x plus 1y equal to 1000 with some conditions, isn't it? So suppose that I need more paper than ink. I'll keep that condition in mind and I'll try to solve such problems. So linear equations is very important in business. Next one is economy. Economy, I'm talking about country's economy. economy, the two main factors which deals with the economy of a country is share markets and forex markets. What is a share market? A share market comes up when a very high-end business person thinks about it launching a new product, maybe a product which costs about 1 crore rupees, and he has two options to pool that money. That is to pool up the money, 1 crore rupees to buy that commodity or to produce that commodity. One way to pool the money is to take loans from the bank. Second way is to sell its shares. That is, the shares of the product can be sold to the public. So suppose I am the Reliance company and I am launching a product with 100 shares, each share costing 100 rupees. Okay, and maybe Lynette bought two shares from it. Then Lynette is said to be a 2% owner of that particular product. Although Reliance is launching the product, now Lynette is a 2% owner of that product, which means she has a share of 2% of that product. So when that product is sold, if the product has a profit, she should be given a percentage of the profit. So that is how share markets work. Now, Lynette has got that share with her, and suppose one share is 100 rupees. If the next day the share has become 101 rupees, then Lynette might think, okay, I shall sell out this share so that I get 1 rupee profit there. Or she might think, I should hold this share so that maybe after 10 days it might become 110 rupees, so that when I sell it, then I'll get 10 rupees profit. Or sometimes the next day it will become 99 rupees. Then Lynette might get scared and sell off the item very fast, because she might think maybe the profits demand has gone very much down and it has become a loss. So then she just sold it and she has a 1 rupee loss. This is the case. This is an example. Okay, this is just when there is a 2% share or something with 100 rupee share. What if the share is a 1 crore rupee share, and if the percentage of share is 65%? Think about the profit, think about the loss, think about how the economy can be affected with share market. So that is one way share markets can be affected with profit and loss. Next one is forex market. Now, what is forex market? Forex market means it is foreign exchange or currency exchange. What is currency exchange? Currency exchange always takes up in pairs. That is, suppose I am thinking about the currency of two different countries. One is the US and the other one is India. Today, $1 is 74.72 rupees. Suppose I'm an Indian, I'm going to America tomorrow. I need dollars in my hand. And suppose that I have rupees 7,472 with me. How much dollars will I get with that? I'll get only $100, because $1 is 74.72 rupees, isn't it? But sometimes the next day, sometimes the rupee equivalent to dollar might be 80 rupees. Then what happens? I will not get $100. I'll only get maybe $93. Then I have a loss there, isn't it? Or suppose the very next day, the dollar is equal to 70 rupees. Then what happens? The rupees, the dollar value has gone down, which means I can have more than $106 in my hand. So I have a comparative profit there. So this is what happens in the foreign exchange market, where people means very high corporate companies exchange their currency regarding or thinking about the profit or loss of the currency. Now, today $1 is equal to 74.72 rupees. If the value of the dollar goes up, that is, if $1 becomes 80 rupees, then it means that the value of rupees has gone down, or the depreciation of the Indian currency has come up. That is, the Indian currency has got depreciated. Suppose $1 has become, okay, 70 rupees. Then what happens? It means that the value of the Indian rupees has been appreciated. It goes up. So all these, the business, the forex market and the share markets, it actually calls for the economy of the country, or it is the very fact which determines the country's development. So profit, loss, percentage, and linear equations have got very important roles in the development of a country. Next is geometry, a part of maths which most of you must have loved in your schooling session, isn't it? Geometry is everywhere in nature, and in spite indirectly to us, it is there in architecture and in computer games. So we use geometry in architecture and computer games. How do we use geometry in architecture? Say, suppose I want to build a house in a space. The architect will come and see the space. He will check what type of geography the space has, the place has. That is it a slanting place, or it is a step culture cultivation, or like that. He will check for the geography of the space. He will also see how much area is there in the space. We'll also see to the fact about the atmosphere, that is, whether there is high wind flow or whether the area is prone to earthquakes or something. And then he decides about the house or the building which has to be constructed in that place. And he builds out that building in a very geometrical fashion, isn't it? He draws the architect draws the design in a very geometric fashion. Now I'll show you two very beautiful architecture which has used geometry. The first one is the Burj Khalifa, the tallest building in the world now. It is situated in Dubai, as you all know. You know, Dubai is a very wind prone place. Very fast winds blows through Dubai. So since this is the tallest building, the architects must have thought how the building can stand this wind, isn't it? So that was done by using this particular geometry. That is, this particular building is in a Y shape, or it has got three petals. The three petals are arranged in the vertices of an equilateral triangle. You can see the the three different petals are arranged on the vertices of the equilateral triangle, and they drew altitudes on all sides, all the from all the vertices, so that it divided the sides into half, and from those half or midpoints they drew the they drew an equilateral triangle, and in the three ends of the equilateral triangle, or the three vertices of the equilateral triangle, there they again constructed three petals, and so on. Inside that equilateral triangle they drew another equilateral triangle. They constructed three petals inside that equilateral triangle, and so on. So what happened? The tallest part of the building had the most strongest foundation, because it had the foundation of the first petal, it had the foundation of the second petal, and it had the foundation of all other petals, which means the tallest part was the strongest foundation part of that building. And here you can see, and here you can see the building has, each part of the building has got different heights. So what happens when the wind flows through the building or towards the building, the wind itself gets confused. So when the wind hits maybe this part, the wind goes to all the other directions, and it goes and hits this part, it goes to many other directions. So the wind itself gets confused. So the total energy of the wind could not directly flow into the Burj Khalifa. That is why it is supposed to be the strongest building. And that is why it has been built very tall, but with very much confidence. The wind could not break the building, or it cannot shatter the building. So that is one application of geometry. This building is this strong because it is constructed in such a geometry. Now, the next one, the Lotus Temple. You know what a Lotus Temple is, or where a Lotus Temple is. It is in Delhi. It is a very beautiful construction. It has got 27 petals in three different layers of 9 petals. You can see that this is the construction is as though the lotus is about to open, isn't it? It is not fully open, or it is not a bud, but the lotus is about to open. You can see that there are 9 free cladding petals, which forms the inner layer of the lotus, which is actually the prayer hall of the lotus temple. Then you have 9 a bit fatter but shorter petals, which form the just outer layer of the lotus temple, which gives more space to the lotus temple. And these 2 layers are inward facing, while you have a third layer of 9 petals facing outwards. These third layer is the 9 entrances to the lotus temple. So since the lotus is about to open, you can see that there is a space over here, isn't it? So if there's a space here, it means that you can have maximum ventilation on the top. So there is maximum ventilation on the top, and you have 9 open entrances in the bottom. So even if the lotus temple is in Delhi, Delhi is a very hot place. Never in any year is the temple hot, or inside the interior of the temple is never hot. It is always cool. It is because of the geometry of the temple. It is because there are 9 entrances for the temple. It is because the petals are kept like this in a particular shape, so that the coolness is stuck in the petals or inside the lotus. That is also one application of geometry. Now, next you study in your schooling is trigonometry. Trigonometry is something so many students hate, but trigonometry is very important in construction, navigation, aviation, computer games, criminology, marine biology, and so many more. So let me first of all tell you how it is important in construction. Okay. In construction, suppose that where now metro rails are very have become common. Like in Kerala, there is a metro rail in Ernakulam. You might have seen the pillars in various heights, isn't it? Some pillars are shorter, some pillars are taller. Why? Because in some places there might be buildings, so the pillar could not be that short because the train might go and hit the buildings. So the pillar should have been taken very much taller than the other pillar. So suppose that the first pillar is 10 meters, the second pillar is 15 meters, and the distance between the 2 pillars is 20 meters. Okay, then you have to put the metro rail on top of the 2 pillars, isn't it? It is a slanting rail. But how can you measure the slanting rail? You cannot stand on top of the air and measure it, isn't it? So for that, you can use trigonometry very simply. How? You can see that the first pillar is 10 meter long, the second pillar is 15 meter long. So the height of the second pillar from the first pillar is 5 meters, isn't it? The difference between the 2 pillars is 5 meters. And the distance between the 2 pillars is 20 meters. So you have a right triangle here on the top, where the hypotenuse is where the metro rail have to be put. And suppose that the angle is here, that is the place where you can see the front part of the metro, isn't it? So that is the angle. Suppose I'm taking the angle as theta. Then I can find theta from tan theta, because tan theta is equal to 5 by 20 in this right triangle, isn't it? So theta is equal to tan inverse of 5 by 20. You know that tan inverse of any angle, tan inverse of any number between -1 and 1 can be found out. So theta can be found out. So you have theta with you. You have the measurement of the opposite side and the measurement of the adjacent side. Either you can find the hypotenuse by using sine theta or cos theta. So that is how the measurement of the rail is taken in metros. Okay. Now, next application of geometry is in computer games, where suppose I think almost all of you might have played Angry Birds, isn't it? So in Angry Birds, you have to pull out a string back, and the bird jumps and goes and hits the target, isn't it? But sometimes, only sometimes, the bird goes and hits the target. Why? Because there is a predefined angle set for the bird, so that the bird goes and hits the target. So here the angle is already predefined by calculating the distance between the angry bird and the target. Now, in the projectile motion, in the motion of the stone or whatever you are throwing to the target, suppose the wind might affect the motion. Then again, there will be some turbulence with the motion of the stone. Then again, at that particular point, that is the second point shown here. And that particular point, again, the angle and the distance should be again found out. So angle is found out again, so that only if the angle is correct at that point, the particular ball or stone or whatever it is goes and hits the target. So that is how you use trigonometry in games. Now I'll just tell you how trigonometry is used in navigation and aviation. See, in navigation and aviation, that is when ships are traveling or when planes are traveling, there are no roads, isn't it? The planes or ships do not have particular roads in which they have to travel, just like how we have roads. So they travel in such a way that they keep in mind the angle. That is, suppose they travel in 30-degree northwest or 25-degree southeast. So they keep the angle, they keep a compass in their plane or ship, and they keep the angle in their mind so that they can correctly measure the angle, keeping in mind the distance between the destination to which they are supposed to reach. So there is a place where trigonometry is used in aviation and navigation. Now in criminology, you might have seen the movie Sediramayar CBI, where Sediramayar goes to the top of the building and he puts a dummy down and he tells that the actual person who had fallen did not fall in the same position and all, isn't it? So in criminology also we use trigonometry. That is, the Sediramayar at that time thought about the angle in which she had fallen. If she had fallen, she would have fallen in a different angle. But if she was taken in someone's hand and just thrown, she would be thrown in a different angle. So that is how he could think that actually the girl was thrown by someone. She was not actually fallen from the building. So in criminology also, angles or trigonometry plays a very important role. Suppose a VIP is shot by someone. Okay, he died, and the investigators want to investigate who has or from where has the gunshot come. Again, the angle is what determines the gunshot, isn't it? So the investigators check the distance and the angle at which the gun was shot. So that is another way in criminology how trigonometry is used. Suppose two cars collide each other and there is an accident. Again, the collision, we can determine a car accident cause by just calculating the trigonometry or the angle of how it had collided. Or you might have seen in industries where the car is manufactured, you might have seen test collides, isn't it? So a car is made to collide with a very heavy object from a particular angle. That is how the engineers work in collisions. That is how the engineers work on how impacted the car will be when in a particular angle a heavy object comes and hits the car. So in every place trigonometry is important. Now suppose in marine biology, I'm telling you trigonometry is important in marine biology. How is that? You know, marine biology means it is the study of marine objects like whales or whatever living objects are there in the ocean or in the marine world. You might have heard that the largest whale is this much feet long, or 150 feet long, and so on. But how can the scientists measure the whale? Can he go with a tape and measure the whale? No. Then how does he measure the whale? He flies above the ocean, and if he sees the whale, he marks the angle from the height of a helicopter to the tail part and the head part of the whale. You know at what altitude he is flying, isn't it? So he has the altitude, he has the angle from which he is viewing the tail and the head of the whale. You can see that a triangle can be formed from that, and like that you can find out the total length of the whale. I hope it is understood. I could not make the presentation in this, the Wales measurement and all in this. So I hope you could understand. So that is how trigonometry affects, or trigonometry is there in our real life. Next, in games you might have also played PUBG, isn't it? PUBG is very common nowadays. What is PUBG? It's a shooting game. So if you are shooting a target, you need to shoot the target in a particular angle. Only then the target is shot, isn't it? So that angle is also predefined by the game processors. So that is how trigonometry is used in games. Next one is functions. Functions is something you study in your 11th or 12th standard, I guess, where function is nothing but a rule from a set A to a set B, where every element in a set A is assigned some element in a set B, isn't it? So you might be thinking, why we are using function, or where we are using function. But before 11th standard itself, you have studied social sciences, where you study atlas, or you study different positions of different countries in the atlas, isn't it? How have this atlas been formed, or how did we draw the atlas from a globe which was actually spherical in shape? So that is drawn. How can we draw the atlas? That is what stereographic projection tells you. Stereographic projection is nothing but a function from a sphere to a plane. Okay, suppose I have kept the globe on top of a plane, atop of a paper, in such a way that the south pole alone touches the paper. Then I define a function from this sphere to the plane in such a way that every point x, y, z on the sphere has got an image UV on the plane. And how it is mapped is, you draw a line from the north pole of the globe through the sphere to the plane. Then you can see that from the north pole, it passes through, the line passes through the sphere, and then it goes and meets the paper, isn't it? So the point at which the line passes through the sphere, suppose it is P, and the point at which the line goes and meets the plane, suppose that is P dash. Then this P, the function gives P is mapped to P dash. That is, every point on the sphere except for the north pole is mapped to the paper. That is what the stereographic projection does. So what about the south pole? What is the image of the south pole? It is that point itself, isn't it? So that is what you see in the second image here. That is the stereographic projection of the globe to the paper. That is what you see in a round image here. But usually the atlas you have seen is a rectangular figure, isn't it? Now, how do we get that rectangular figure? That is got from something called the Gauss stereographic projection. That is done by keeping the globe inside a cylindrical, or inside a cylinder, and drawing lines from the center of the globe towards the cylinder, so that the lines passes through the globe and goes and meets the cylinder. So every point in the globe meets the cylinder, and thus every point on the globe has an image in the cylinder. Now the cylinder will have so many images from the globe. That is, the cylinder will be covered with the atlas. Then how can we get the atlas, or in this form, that is in the form that you see in the third image? You just cut the cylinder and keep it straight. Then you get the atlas. So that is how you actually got the atlas. First you had the circular atlas, which was actually got from the stereographic projection. And then there is the Gauss stereographic projection, where you keep a sphere inside a cylinder to get the image of the atlas. Now, there are some drawbacks for the stereographic projection. That is, the maps, or the images of the globe and the images of which you have got in the atlas, they might not be isometric. That is, they might not be distance preserving and area preserving. That is the only drawback of the stereographic projection. But there are mathematicians working on it to make accurate isometry between the images also. So that is how function is related to what you have studied in your social sciences. Now, next is linear algebra. Linear algebra is something that you are going to study in your third year maths class. Linear algebra is nothing, but it is basically a study of vectors. It is a study of vectors, the linear equations of vectors, then their various properties, their functions of vectors, and so on. The functions on these vectors or on the vector spaces, that is a set of vectors, is usually called the linear transformation. And basically, there are four linear transformations. That is what I have shown here, the four basic linear transformations. One is scaling. Scaling means t is a function from a set to the other. The function is defined like this. That is t of ordered pair xy is equal to lambda of xy, which means you can see two figures here, isn't it? That means first you have a small rectangle. When you give lambda or when you multiply lambda with this rectangle, if lambda is greater than 1, then what happens? This rectangle is expanded. That is what you see in the second figure. Rather, if the lambda is less than 1, then what happens is that this figure will become that is, it will become smaller of what it is actually. So this is how scaling is done in linear algebra. Next one is reflection. Reflection means there are three types of reflections. They are just simple functions where the ordered pair xy is taken to its reflection x minus y. So suppose you have a point xy here, and suppose its image is x minus y. It means that if you consider the y-axis as a mirror, then xy's image falls on x minus y, isn't it? So that is a reflection considering y-axis as your mirror. Now suppose that t of xy is equal to minus xy, or xy is mapped to minus xy. Then what happens? You are keeping x-axis as the mirror, and then this xy will have a reflection minus xy. So that is the reflection of xy when x-axis is kept as the mirror. Now the last one, that is t of xy is equal to minus x minus y, means you have a mirror on the origin. Then what happens? This xy's reflection will fall on minus x minus y. So that is what reflection is. Next is rotation. Rotation is nothing but you are rotating the particular point to a particular another point through a given angle theta. That is all what is rotation is. So the rotation has got a particular format. It is given as the matrix multiplication of cos theta minus sin theta cos theta into xy, so that the point xy rotates through an angle theta and moves to the point t of xy. Next is translation. Translation means you are just moving a point xy to some other point, say x plus a1, x plus a2. So these are the four basic functions or linear transformations in linear algebra, with which actually every linear transformations can be defined. Okay. Now with this linear algebra, game processors can process the games, or they program the games out by using these four very basic linear transformations, and I'll show you how it is. So here you have a car. In the first image, you have a car, and there are three arrows shown in the first image. After the first arrow, you can see that a car is moved a bit, isn't it? That means that a function has been assigned to the car to move a bit forward. That means the car has been translated from the point where it was to the point where now it is. So there you have used linear algebra to translate the car. In the next arrow, you can see that the car is a bit tilted anti-clockwise, isn't it? So there, the rotation function or the rotation transformation is used to rotate this particular car in a particular angle. Next arrow is where the car has become smaller. So there, what have we used? We have used the scaling transformation. Now, in the next one, you can see a ship on top, or a sail on top of a plane. And the sail is now standing on the position 1, 2, isn't it? Suppose this is the x-axis, that is the horizontal axis is the x-axis, and the slanting one, or the one which goes into the phone or into the laptop, is the y-axis. Then the sail stands at which point? It stands at the point 1, 2, isn't it? The ordered pair 1, 2. Now, suppose I want to move the ship from the point 1, 2 to the point 3, 1. Then what I should do? I should just translate the ship by giving the function t of xy is equal to what? T of xy is equal to x plus 1 y minus 1, isn't it? Sorry, x plus 2 and y minus 1. So whatever is there here will be translated through the x-axis 2 units forward and through the y-axis 1 unit backward. So that is how we use linear algebra in game theory. After all, it is not used directly, but it is used by the game programmers to program the game by using, various programs, isn't it? Like C++ or various other programs. They use inside the programs, they use such functions to translate or to move the objects in the game. Okay, so that is our linear algebra. Now, next is a very interesting thing. You all might have accounts in Twitter or Facebook or Instagram or any other, at least one social networking site, isn't it? So this social networking uses a very important subject in mathematics, that is the graph theory. You might have studied graph, isn't it, in your schooling? What did you do? You had some points, you had to mark it in a graph paper, and you had an equation of a line. You wanted to plot the equation. So what you did is that you found out certain points which satisfied the equation. You plotted those points and you drew lines between them, isn't it? So there you were just dealing with points and just lines or line segments. Here we are dealing with real world entities or real world items. Now there the points or the ordered pairs, say 1, 2, 2, 1, etc. All those are called vertices in graph theory, or a vertex. A point is called a vertex. And the line segment between two vertices are called an edge. Okay. So in real life, how can we bring graph theory, or how can we bring in this vertices and edges? Vertices is given to any element in a set. So suppose the set given to you is a set of people. The set of people now you can see in the screen. All these people are vertices, or they are just points. They are considered as points. And there is an edge from one person to another if they are related in some way. In social network, how are they related? They are friends in some social network sites. So here you can see a girl smiling at you, a big picture. You can see an icon of Facebook where the girl is related to two other girls and a man is related to a girl with open hair, isn't it? So you can see that this particular girl who is looking at you and smiling has got two friends in Facebook. And then she has got so many friends in iCloud, isn't it? That cloud is iCloud. She has no friends in LinkedIn. She has got some friends in Google Plus and so on. So some days when you open up Facebook, you will see certain notifications like the people you may know. Those people may not be the ones you know directly, but she might be a friend of some other person you might know, or a friend of friend, or a friend of your friend, isn't it? How did that notification pop up? It popped up because it used graph theory. That is, here in Facebook, this girl was related to two other girls, isn't it? And here in the icon with the cloud, you can see a man. So sometimes that man, when he opens up the Facebook account, sorry, the cloud account, he might get a notification that you may know the girl with the girl having her hand on her face. I hope you can see that girl. How did that come up, that notification come up? It came up because this girl and the man was friends with the same person. That means you had two adjacent vertices. So if you have two adjacent vertices, it means that the vertex on the end of the adjacent vertices might be related or can be related in some way. So that is how graph theory is used in social networking. Okay, so now you have seen many uses of isn't it? Now, max is also used in chemistry. In chemistry, you might have seen how max is used by the differentiation is used in finding out the rate of change of the energy of a particular item, or it might be used to find out the time taken by the electron to emit its energy, or differentiation can be used to find out the maximum melting point or the melting point of a particular substance, which means you have to burn that substance to a particular point, to a particular maximum point. At that point, the melting point occurs, isn't it? So max is used in chemistry also. In physics, you might be very much knowing about divergence, torsion, radius of curvature, etc. Isn't it? You have all studied it in second year, I guess. Then you know that, okay, I didn't talk about differentiation and integrations applications because you already know the applications. You had already studied it in your 12th standard. What are the applications? Differentiation have got the application of finding out the maximum or minimum of certain functions. Integration has got the application of finding out the area of certain very complicated curves or very complicated solids, etc., isn't it? That is why I didn't include integration and differentiation here. But what about in medicine? In medicine also, mathematics have got a very important role, like in scanning. You might have seen MRI scans and ultrasound scans and all, isn't it? So there is a branch of mathematics which is called the wavelet theory, which actually gives precise scanning methods or precise MRI scans or precise ultraviolet scans. The scans also uses linear algebra. Why? Because you have seen the images which can be expanded, isn't it? That is expanded by using scaling. That is used by using linear algebra. So there is mathematics everywhere, wherever you look, irrespective of whether you are completely related to it or not. So it is indirectly related to you. Even in medicine, mathematics is there. But what the mathematicians have a keen eye of seeing mathematics everywhere. And so we have found out mathematics even in nature, that is even in the lightning. Now, the mathematics we have found there is fractals. I don't know whether you have heard about fractals. Fractals is nothing but curves or geometric figures, each of which has the same pattern and character but different sizes. So in this lightning, you can see a very bright stem of the lightning, isn't it? And all other lightnings have got the same shape as that bright stem. That is, they are actually reflecting the same lightning itself, the same stem lightning itself. That is, they have the same structure and characteristic. That is, a lightning's energy is the same throughout in all the curves, isn't it? They have the same characteristic and the same structure, but the only difference is in their sizes. Same thing about a tree also. In a tree, you have seen a bark of a tree, that is a very thick bark. From that bark, the tree divides into branches. The branches again divides into stems. The stems divides into twigs. The twigs into leaves. And inside the leaves, you have seen, isn't it? Seen like veins. You have seen patterns like veins. Again, all these are actually the same structure of the tree's bark. The same structure is repeated again and again with the same characteristic, but with a smaller size or with a size difference. So that is what actually fractals is. Fractals is nothing but complex patterns that are all self-similar across different scales. Okay, they have got different scales, but they have the same pattern and they have the same characteristic. So fractals are everywhere in nature. Even when you look out of your window, you can see fractals, that is in trees also. Fractals is inside your human body also. How can you see fractals in your human body? Can you see my presentation? See, in a human body,
We can see it. Aishwarya ma'am, also, can we wind up within 5 minutes?
yeah, okay, sure.
Ah, ah, thank you.
In fractals, okay. So in our human body, you can see the circulatory system. Okay, I'm not speaking about it much. The circulatory system, that is, first you have the artery, then the pulmonary artery, then the pulmonary vein, then the veins get smaller, the main veins, the smaller veins, and so on. Isn't it? That same structure is repeating. The same thing happens for the lungs also, where you have the main bronchi, the secondary bronchus, the tertiary bronchus, and lastly you have the bronchioles, isn't it? All with the same structure. Okay, now in beauty also we have got max, that is in golden ratio. Golden ratio is nothing but a ratio connecting two numbers. That is, if you have two numbers A and B, A greater than B, then A and B are related with a golden ratio if A plus B by A is equal to 1.618033, etc. This is called the golden ratio, or it is also called the divine proportion, because whatever you do in a golden ratio, if an architect builds out a building in golden ratio, using the golden ratio, that building will become very beautiful. That is what the golden ratio tells. So you have seen the painting of Mona Lisa by Leonardo da Vinci, isn't it? That is supposed to be the most beautiful painting even in this century, because he used golden ratio to paint that particular painting. Next, in beauty also, Bella handed it the woman with the perfect face. She is supposed to have a golden ratio in her face, that is, the measurement from her forehead to her eyes divided by the measurement from her between the eyes to her nose is a golden ratio. Similarly, the measurement from the eyes to her nose and nose to her chin also is almost a golden ratio. In India, Aishwarya Roy is the lady with almost the golden ratio, but in this century, Bella Hadid is supposed to be the most perfect face with respect to the golden ratio. Now you have seen everywhere max, isn't it? Now, if you tell me whatever in the real life, I can connect it with max by using some function. For example, if you tell me two places like Trivandrum and Ernakulam, I can connect it with a particular function or a particular real number, that is the distance of the real number. Sorry, the distance between the two places, Trivandrum and Ernakulam. That is the very basics of metric. Metric is a function and it is defined from a set to another set, m cross m to m, where it satisfies just four properties. That is, the function is, suppose I take x as Trivandrum and y as Ernakulam, then you know that the distance between Trivandrum to Trivandrum itself is equal to 0. That is what is given as rho of xx is equal to 0. Next, you know distance is always greater than 0. That is why x of rho of xy is greater than 0. You know the distance between Trivandrum and Ernakulam and Trivandrum are the same. Either you go from Trivandrum to Ernakulam to Trivandrum, both are the same. That is why you have rho of xy equal to rho of yx. And the triangular inequality is saying that if you travel from Trivandrum to Idukki and Idukki to Ernakulam, or if another person travels from Trivandrum directly to Ernakulam, who will reach faster? Of course, the person from Trivandrum to Ernakulam directly will reach faster. That is what is said here. That is, rho of xy is less than or equal to rho of xz plus rho of zy. So whatever real entity you tell me, I can find out a real number connecting to it, or I can find out a max connecting to it. That is why we mathematicians should be very proud to be a lover of maths. So okay, let me now wind it up. Now you know why the maths is called the queen of science, because it is there everywhere and anywhere in the universe, and it is you who should change your perspective of thinking what maths is. You should be the one who loves maths and thinks maths in everything you see. Okay, so we teachers in this particular curriculum, we do not have the chance to give you another level of mathematics or another dimension of mathematics, because the less time we have. You know that, isn't it? But you can actually debate with yourselves. You can actually explore a lot about maths. You can debate with yourself, quarrel with yourself. You can talk a lot about maths with yourself. So we have given you a base. You just have to construct on top of it. explore more on mathematics. You have got so many opportunities, so many sites there regarding mathematics. Please do surf the sites and check for the applications of mathematics. So you can now see that Max has got a very bright future. There is a very good career opportunity for mathematics, and also the sister subject of mathematics, that is statistics, which is very inevitable now in the development of the country. It is a subject which is drastically developing now. So try to find out another levels, different dimensions of mathematics or statistics. I'm thanking you all. Before that, let me show you one last slide. That is, it is the keen eye of a mathematician that spots the application of maths in every little thing we do. So actually, nature is completely with mathematics, but only a person who has studied mathematics, who has understood mathematics. I think a person only after his or her PG or after MPhil can he think maths in such a way. So I would like to hear that you all are going for research. I would love to hear that you are going to study more and more about mathematics. Please do go. Please do fly high in maths. I am thanking the department of the college for inviting me for such a talk and keeping you all together in such an innovative idea. Thank you especially to Smita ma'am and Lynette. Thank you so much. And please do be safe. Please stay safe. Please don't go outside your houses without any reason and all. Please do be safe. Let us fight this virus, all of us. Let us all of us be together and fight this virus. Let's all come back to the college very soon. Thank you. Thank you so much.
Thank you, ma'am. It's a great happiness to have someone like you, ma'am, to be with us to enlighten us this evening with Burj Khalifa and Dubai and even PUBG at our fingertips and telling all the math in it. Thank you, ma'am. Now I would like to invite Lynette, ma'am, Assistant Professor, Department of Mathematics, Secretariat College, Chalakudi, to express vote of thanks.
Hello, am I audible?
Yes, you are.
Okay, so it is a great happiness to have Aishwarya ma'am with us in this occasion. And in spite we have informed her in a very short span of time about the session, she presented us so well. About the various applications that we see in real life about mathematics. I have the privilege to have been a student with Aishwarya when we were doing a degree program, MPhil degree program together at Cochin University. So she is such a good soul at heart, a lot of helping person, and also has good insights in mathematics. So thank you for being with us and sharing all of the great things you shared with our students. I think that students have been very much inspired by your session. So thank you. Thank you from the Department of Mathematics, Sacred Heart College, Chalakudi.
A student with Aishwarya.
when we were doing our degree program, MPhil degree program together at Kochi. And
Lynette, end the meeting.
Okay, thank you all. Shall I leave the meeting?